Okay, so now I'm going to do example 3. It's a bit tricky compared to example 1 and example 2. So example 3 says, so you are asked to find the integral of x sine x cos x with respect to x, right? So it looks tricky at first, but it's actually an easy one because you know you have that identity that says sine 2x equals 2 sine x cos x. So knowing this, we can actually divide both sides by 2, so we can get half sine 2x there. It becomes, because if 2 sine x cos x is equal to sine 2x, then sine x cos x has to be equal to half of sine 2x, right? So it actually makes sense. So we're going to write that sine 2x equals half of sine 2x is equal to sine x cos x. So we are then going to make that replacement in our integral. So our integral now looks like this. It now looks like half x sine 2x dx. So now, applying the formula for integration by parts, which says the integral of u dv over dx equals uv minus the integral of v du over dx, right? So we are going to let our u be, so I advise that you put this half inside so that you avoid because if you put it outside, for example, if you then forget to multiply your whole answer by half, then it's going to be wrong. So I advise that you keep it inside so that you don't make any mistakes. You actually include it when you pick your u, right? So I have chosen my u to be half x in this case. It then means I'm going to say, so let u equals 1 over 2x. It means du over dx becomes half, right? dv over dx automatically becomes what I didn't choose as u, which is this here. So I can actually put this in pink. It's that thing. That's my dv dx. So dv dx is going to be sine 2x. So this is sine 2x, right? Now, my v is going to be the integral of this derivative. So it's the antiderivative of this derivative. So sine 2x is actually a derivative with respect to x of some function v. If I want to know what that function is, I have to find the antiderivative of this derivative. So it then means I can say, so here's what you do when you're integrating something like this. You derive the inside function, so derive the inside function, right? What do you get? You get 2. You divide by that 2. Then you integrate the outside function, which is sine. So it's just sine, nothing else, just sine bracket. That's going to give me, as I said in the last example, I said that if you integrate sine, you get minus cos. So here you get minus cos bracket. Then you put back whatever was inside in the beginning. So that's what you're going to have for v. So now we're going to plug that into our formula for integration by parts. If we do that, we're going to have the integral of x sine x cos x dx, which is what we initially had. It's equal to uv is going to be half x multiplied by minus cos 2x over 2. That's going to give us minus x cos 2x over 4, isn't it? So that's going to be over 4. Then we're going to say minus. Now, this minus that I put here is the negative sign that is in our formula for integration by parts. So I'll have to put my integral sign, then put my v. But also my v has a negative sign. So that since I'm going to put v here, and I know it has a negative sign, I can factor that negative sign out of the integral sign, and I'll actually put it here, it becomes a plus, because we have 2 negative signs there, if we consider the negative sign that v carries. So we now have a plus. And then we can also then take note of the constants. We have half, because remember it's going to be v du dx. So we have this half that comes with v. Then we have this half that comes, so I'm talking about this over 2 here, it's a half as well. And this half that comes with du dx. So I'm multiplying v with du dx. So those halves will also multiply and I get a 1 over 4, right? After getting that 1 over 4, I will then say, what do I have left? I've dealt with this half, I've dealt with this minus, I've dealt with this over 2. I'm now left with cos 2x. So that's what I'm going to put here. And I'm integrating that with respect to x. So now I have something like this. So this becomes x sine x cos x. We are changing nothing on this side. It remains the same. There we have x cos 2x, right, over 4. So it's minus x 2x, minus x cos 2x over 4, plus 1 over 4. Now I have this integral, right? I can put a bracket here. Why am I putting this bracket? So that it reminds me that what I'm actually looking for is the solution of this integral. I cannot have an integral inside the solution. So I want to have a solution of this integral. I will remove this integral from the bracket and put its solution, because I have to give a full answer, right? So then, if I integrate cos 2x over, so it's just cos 2x, right? So cos 2x I get 1 over 2, because I have derived the inside, I divide by that 2, and then I get sine 2x upon integrating the outside. So I have sine 2x, I put back whatever was inside. Then plus our constant of integration c. So that's going to give me the integral of x sine x cos x dx is equal to minus x cos 2x over 4 plus, that's going to be 1 over 8 sine 2x plus a constant of integration c. So that's my solution right there. That's my solution. Yeah, so that's the correct answer here.